HL counting and binomial addendum, page 1. First, we're going to talk about the product principle, which is a arithmetic method of finding all the different ways of completing a task. In this case, we have a road trip from point A to point C via point B. And there's 4 rows to choose from between A and B, and there's 2 rows to choose from between B and C. And we'd like to figure out all the different ways we could go from A to C via B using these roads. So basically, we're going to list out every single possibility. So we have 1A, 1B, 2A, 2B. So that's basically take road 1. And then take road A. Take road 1, then take road B. Those are 2 different ways of getting from A to C, correct? So we're going to do that for each of the roads. And we'll find that there are basically 1, 2, 3, 4, 5, 6, 7, 8 ways, 8 different ways of going from A to C via point B, right? So we'll put 8 here. This is called the product principle because you can find the number of ways by calculating 4 times 2. So you don't have to sit there listing out every way. You could just take the number of ways you could complete the first task, 4, and then count up the number of ways you could do the second task, 2, and multiply them together. Okay, the illustration here shows different map routes for a bus service that goes from P to S through both Q and R. How many routes are possible? Okay, so in this case, what we can do is we could say, well, there's 3 routes between P and Q, there's 3 routes between Q and R, and there's 2 routes between R and S. The way we could figure out the number of distinct routes that are possible is we'll do 3 times 3 times 2, which will give us 18, and that will be the number of different routes possible to go from P to S via Q and R. Number 3, the wireframe shown forms the outline of a box. An ant crawls along the wire from A to B. How many different paths of shortest length lead from A to B? To make this a little easier to understand, I took the different routes to go from A to B and I flattened them out and made them into this little diagram here. You can see that from A, you can go to the corners 1, corner 2, or corner 3. From corner 1, 2, and 3, you could go to corner 21 or 22 from corner 1. You could go to 21 or 23 from corner 2, and from corner 3, you could go from 22 to 23. From 21, 22, and 23, you can go to corner B. And there's other ways you could go from A to B, but those are the only ways to go in 3 sections. If you went from 1 to 22 and then to 3 to 23 to B, then that would be a unique path, but it wouldn't be a shortest length path. Okay? So basically you have these possibilities. So basically the 2 possibilities you have if you first go to 1 would be via 21 and via 22. So that's basically 2 routes that lead from if you choose 1 first. If you choose 2 first, there's also 2 possible routes via 21 and via 23. And then if you choose 3 first, there's also 2 possible routes via 22 and 23. So basically you have 3 times 2 routes, which would be 6. Number 5. A football competition is organized between 8 teams. In how many ways can the top 4 places be filled in order of premiership points obtained? What that looks like is I have teams 1 through 8, and then I have 4 positions. In these 4 positions, I want to put 4 of these teams, and when I fill in these, like for example, I could put team 1, 2, 3, 4, for example. I could put 5, 6, 7, 8, for example. I could also put them in different orders. I could have 1, 2, 3, 4, or I could have 4, 3, 2, 1. So you can see there's a lot of different ways to do that. Basically, to calculate that, what you would do is you would take each of the positions, and you can only fill in each position with one team, and once you've used the team, you can't use that team anymore. So in the first position, basically you have a choice of 8 different teams. In the second position, you only can choose from 7 teams because you've already used one of the teams in position 1. In the third position, you can only choose from 6 teams. And in the fourth position, you can only choose from 5 teams. So basically, we can find the number of ways we can fill in those slots by doing 8 times 7 times 6 times 5. That would be about 1,680. How many different alphanumeric plates for a motor car registration can be made if the first 3 places are English alphabet letters and the remaining places are 3 digits from 0 to 9? So the first 3 positions have 26 possibilities for each one. So 26 times 26 times 26. You can repeat letters, right? So you don't have to go 26, 25, 24. It's just going to be 26 times itself 3 times. And then the remaining 3 digits, basically you have 10 digits to choose from, 0 to 9. So you would have 10 times 10 times 10. And this you would just multiply on the calculator, and you would end up with 17,576,000. Moving on to page 2. For 8b, counting paths, page 246 reading. So let's study the way we would go from point P to point Q along all these different routes. If we were going to go along this central path here, and we wanted to go from B to G, then you could see that we would go from B to E, and then we would go from E to G. Okay, so like when we go along this path, we have these choices to make and these choices to make, and the way we do those is we do one and then we do the other, right? What about if we're going from P to Q and we're going to go down the A path, or we go down the B path, or we go down the C path, okay? Do you see the language we use here? When we go along this path, we do this path, and then we do this path. We use the word and. If we're going to go down this path, or this path, or this path, we use the word or. The words and or give us a clue as to how we find the total number of paths, okay? So if we're going down here, we can see that there's 3 choices we make between B and E, and then there's 2 choices we make between E and G, and since we use the word and, we're going to combine 3 and 2 by multiplication, okay? So the middle path here, we find that there's 6 different ways of completing this course, and we find it by 3 times 2. Okay? Now, there's 2 ways of completing this course, and there's 3 ways of completing this course. If we want to find the total different number of ways that we could go from P to Q, remember we could go this way or this way or this way. Since we have combining these 3 paths with or, we are going to add them up. 2 plus 3 plus 6. This one is 6 because it's 3 times 2. So just going to fill in the numbers here. So from A to Q, we have 2 options. From C to Q, we have 3 options. And from B to Q, we have 6 options. And the way we found 6, we did 3 times 2. How many paths from P to Q total? We add 2 plus 6 plus 2, and then that gives us a total of 2 plus 6 plus 3, which gives us a total of 11. Okay? And so we found that by addition, right? And this is what I was explaining before. So if we say and, Then we're going to do multiplication. And if we say or, like A or B or C, then we're going to do addition to find the total number of paths. Okay, 1A, how many different paths lead from P to Q? So here we have 2 here, 2 here, 3 here, 3 here. Since one comes before the other, so you do this one and then you do this one, it will be 2 times 2 is 4. Since you do this one and then you do this one, it would be 3 times 3, which is 9. And then you could go this way or you go this way. So the way you would combine 4 and 9 is you would add them. So 4 plus 9 equals 13. What about C? So here we have two possibilities. We have 4 possibilities, then 2 possibilities. We have 3 possibilities and then 3 possibilities. So we have 2 on this path. We have 2 times 4, which is 8 on this path. And this one we have 3 times 2, 9 on this path. So we combine this path or this path or this path by adding. So 2 plus 8 plus 9, which is going to be 19. Number 2. Katie is going on a long journey to visit her family. She lives in city A and is traveling to city E. Unfortunately, there are no direct trains. However, she has the choice of several trains which stop in different cities along the way, and these are illustrated in the diagram. Okay, how many different train journeys does Katie have to choose from? So she's going from A, and she's going to E. And there's 3 possibilities here, and there's 2 possibilities here, and there's 1 possibility here. There's 2 possibilities here, and there's 2 possibilities here. So I would combine these 2 with addition, because you could go from B to E using the C route or the other route. So since it's or, you would combine them with addition. So this would be 3 possibilities. And then this 3 and this 3 would be combined with multiplication, right? So going down the purple route, you would have 9 possibilities. And then going down the dark blue route, you would have 2 times 2 possibilities, 4. And so you would combine the 9 and the 4 by adding them together. So there would be 13 total possibilities.